If you have polarized sunglasses, you have a quantum measurement device.
Each of these pieces of glass is what's called a polarizing filter, which means when a photon of light reaches the glass, it either passes through or it doesn't. And whether or not it passes through is effectively a measurement of whether or not that photon is polarized in a given direction.
Try this. Find yourself several sets of polarized sunglasses or old photographic filters. Look through one set of sunglasses at some light source, like a lamp, then hold a second polarizing filter between you and the light. As you rotate that second filter, the lamp will look lighter and darker. It should look darkest when the second filter is oriented 90 degrees off from the first. What you're observing is that the photons with polarization that allows them to pass through a filter along one axis have a much lower probability of passing through a second filter along a perpendicular axis. In principle, zero probability.
But here's where things get quantumly bizarre. All these filters do is remove light. They filter it out. But if you take a third filter and orient it 45 degrees off from that first one, and then you put it in between the two, the lamp actually looks brighter. This is not the middle filter generating more light. Somehow, introducing another filter actually lets more light through. With perfect filters, if you keep adding more and more in between at in-between angles, this trend actually continues. More light.
This feels super weird, but it's not just weird that more light comes through. When you dig in quantitatively to exactly how much more light comes through, the numbers don't just seem too high, they seem impossibly high. And when we tug at this thread, it leads to an experiment a little more sophisticated than this sunglasses demo that forces us to question some very basic assumptions we have about the way the universe works. Like that the results of experiments describe properties of the thing you're experimenting on, and that cause and effect don't travel faster than the speed of light. These will come into question.
Where we're headed is Bell's theorem, one of the most thought-provoking discoveries in modern physics. And to appreciate it, I really do think it's worth understanding a little of the math that we use to represent quantum states, like the polarization of a photon.
Well, at this point, I am very confused as to what I just heard. But I thought I would take a stab at why Bell's theorem presents this paradox. In other words, if you put a filter at 45-degree angles, it allows 50% of the photons to pass through. And then when you turn it at a 22.5 angle, which should only allow 75% of the photons to pass through, it actually allows 85% of the photons to pass through, which makes no sense, at least if you're thinking in a linear state or if you're thinking in Euclidean geometry. It doesn't make much sense. But I think I remember something from my paper that might help me at least propose a resolution or a solution to Bell's theorem. And it has to do with a Schwarzschild metric and how photons travel and on which axes they travel and how they interact with each other. So here's the Wikipedia page on the Schwarzschild metric. And it's a very elegant metric if you want to view it. Schwarzschild, as you know, was a astrophysicist that wrote during World War II to Einstein his solutions to Einstein's field equation, and he came up with the Schwarzschild radius. And basically here is the equation for the Schwarzschild radius. And if you see, here's a radius of a black hole, a radius of an electric hole should equal these two equations. So what you have is you have a 12 radius squared over a radius times 6. That's 2 cubits, okay? Or, so that should be, you're looking at a 3-dimensional space here, okay? And it should equal a 48 g squared, and that's that is the constant for gravity, Newtonian gravity. So you are going to have 48 times the gravitational constant squared times the mass squared, and that's going to be divided by C4 over a radius of 6. See how elegant that is? We are reduced to 12 radial spaces here over, and it's going to happen on 6 metric points or 6 axes or vertices. These are 6 axes. Same here. We're going to have C4 at 4 axes, but the radius is going to be 6 divided by the gravitational constant, but 48 gravitational constants. That's the time it's going to take to travel this area. Okay, let's go on down here. Now the orbital motions. Okay, we know stars are made up of photons. So those stars are going to be traveling in orbital motion. So photons are going to be traveling in a particular pathway. And it's going to be according to the Schwarzschild geodesics, or what they call the Schwarzschild lattice. But I want to show you the animation which explains this lattice effect. But first off, let's just talk about what this is saying right here. It is saying the non-circular orbit, such as Mercury's, dwells longer at a small radii than would be expected classically. This can be seen in the less extreme version of the more dramatic case of the particle passes through an event horizon. Okay, so let's take a look at this animation that I find very fascinating. So over here we've got Newton's versus Schwarzschild's trajectories, and you can see on a Newton plane you simply have an orbit going around a particular point. And down here you've got the time, but we're going to look at the time dilation. The time dilation for a Newtonian physics is 1. Okay, but Schwarzschild is much different. There's a time dilation that allows an expansion of the photon to travel in this flower-like effect. So let's take a look at what we are seeing here. Okay, we're going to start at 1. When it reaches its first path, proper time. So it's starting over again right here. Now 1, it goes around a central path, but every time it goes at a particular lattice-like fashion, and it forms a flower effect. So it's rotating, rotating, rotating at certain angles around a particular point, or its central point. And look at the time dilation. So the time dilation here is greater than 1 at all times. You're going to have 1 just when you start over, but you can never have 1 completely, or it will collapse into a black hole. But as you can see, it's always slightly higher than 1. And we've got the x and the y axis. So this is simply in a 2-dimensional plane, or you're looking at a cubit. But we live in a 3D universe, so this is going to be happening at a different dimensional space, and it's going to be intersecting with this Euclidean space. And that's going to explain what's happening to the photons in Bell's theorem. What is also going to assist us in finding a solution for the Bell's theorem is the Maxwell-Faraday equations. But let's start out with Gauss's law. And Gauss's law for magnetism states there are no magnetic charges called magnetic monopoles analogous to the electric charges. Instead, the magnetic field due to the materials is generated by a configuration called a dipole. So he's saying the magnetics really has no real charge to it, not like the electron, or not like the photon. The photon has a charge. The magnetics of Gauss's law does not. Again, going back to Schwarzschild, according to Wolfgang Pauli, Schwarzschild is the first to introduce the correct Lagrangian formalism of the electromagnetic field, and here it is, 1/2 minus where E is the electric and magnetic field, so we've got the magnetic minus the E squared, leaves a remainder plus, then we've got potentials here of the magnetic potential and the electric potential. And those are the Lagrangian, and they go in one direction, as you can see. They're always going to go in a forward direction. So here we have it, Schwarzschild in a relativity diagram, and you're going to see how quickly, if we use Schwarzschild's equations, you're going to see there's this strong pull upward to almost infinity, and then it falls back, and it goes slow, 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 then it's going to hit and go again. So there's this whoosh. We're going to get 1, 2, 3, 4, 1, 2, 3, 4. Anyway, it's like a heartbeat. It's this 2-step dance. You get 2 steps forward, 1 step back. 2 steps forward, 1 step back, and it's going to go forward. Just the magnetic field only pulls it halfway back to its starting point. It pulls it back to its number 2 position, then it goes again. It's going to pull it back to number 3 position, then again, and number 4. So you're always having 2 steps forward. Actually, this is 4 steps, but then it comes back to its second position. 2 steps forward, 1 step back. And that's called the 2-step of the Schwarzschild metric. And as you know, everything in the universe dances according to that same metric. that same two-step. Everything goes in a clockwise or counterclockwise, depending on your torsion field. You're going to get 2 steps forward, then you're going to have the magnetic pull back of 2 steps forward, which is a photon that travels twice the speed of an electron, and then 1 step back as the electron or the magnetic field pulls the photon back, and that causes the flux. It's the boomerang, it's the flux that gives electromagnetic fields and electricity its charge and its force. It's the flux of these interweaving 2 steps forward, 1 step back, or 2 steps forward, and then boom, a new photon is created. Here is a man who developed and further enhanced the Schwarzschild theory by adding the Schwarzschild series coordinates. And these coordinates provide a lattice type structure to the universe. And it proposes that the universe is made up of a cellular type of membrane, similar to organic matter. Our cells have an outward shelf, and they are connected by coordinated or adjoining cells. But each cell is individuated by an outer shelf, which we know that the electron also has an outer shelf. Photons do not have outer shelves, they basically radiate. And we know that the photon travels at C, the electron travels at C2, which is not as fast as C. So here we have basically a animation of the Schwarzschild theory, and it shows that the energy flows toward each other at right angles, and then it retreats at perpendicular right angle. But then once it retreats, it goes over to this energy lattice point, which is half of a 90-degree angle, and it's a 45-degree angle, and the energy hits again and goes outward in a different energy area. So here we've got the energy going here, but then when you twist it like a clock at 45 degrees, then the inward and outward energy twist. What he was also significant is that this is not in a linear fashion. These white holes, black hole configuration is basically black holes on the outside creating the outward shelf. Interior of the black hole is a white hole. So every white hole, which is an electric field, has an exterior electron type shelf or black hole event horizon that we can't see into. So what we're seeing when we look out at space is simply a cellular construction that we cannot see inward at the inward lighted area, or the electric field white hole within the black cellular event horizon. And we've all seen this animation or this funnel before. This is called the paraboloid of the Schwarzschild. But these are all the energy funneling out, and it creates a torus because it doesn't just go out forever. It will curve right around and come back in again in that flowering shape that we see in the Schwarzschild metric of the universe versus the Newtonian. But this is one part of the inward energy and outward. So here is the positive pole, and here's the negative pole, and then it goes a 45-degree angle and goes back in again. Whoops, there we go. Anyway, it goes in these intricate turns, and they keep turning and turning and turning and turning, going in and hitting and turning out and turn. It's like the turn of the screw or the ticking of the clock. It keeps on rotating, but it's always in a forward motion because it's 2 steps forward, 1 step back, because the magnetic pull is not as significant as the forward movement of the photon. So let's also look at the geometry of a regular hexagram. And here we're going to see this hexagram and the group theory of how it continues to move out and inward and out and inward and out. Here's the magnetic, here's the G2, here's the A for area. But it's also telling you this is the construction of the compass. And look at this. The magnetic field is 1/3 the energy level of the electric. Flip it back and forth, but you're going to have 1, 2, 3. So that's 3. The hexagram is shown all through history. Here's the Dharmic religion. Here's the symbol for the heart chakra. This is the Star of David. This is on the Mormon Assembly Hall. Here it is in Morocco. We have this hexagram in every religion. Here it is in Delhi. So the ancients were very well aware of the configuration, the geometry, the sacred geometry of the universe in which light and energy traveled in these intricate patterns made up of the hexagram. Here we have it used in the Quran. Here we have it again. And I believe that, I don't know what that is. That's a big owl in Washington, I guess. Oh, it's Heathrow Airport. Okay, enough. I'm moving on to the pentagram. So here we have a simple pentagram. Pentagram is shown all through. And what you're going to have is the Schwarzschild metric made up of the hexagram and the pentagram as it moves in a circular fashion at 22.5 degrees. And we're going to show you, here it is, this pentagram. And you have all sorts of configurations, but this especially is the pentagram of Venus. You have the 5 circles, and as we saw, the Schwarzschild had a 10 circular flower. This is a 5 circular flower, but you combine 2 of these and you're going to have a 10 circular flower pentagram of Venus, which is the Schwarzschild metric animation. Here is a basic Schwarzschild geometry. The magnetic field and the electric field should equal 1. 12 lines of force. The magnetic field is 1/3. So what you have is 6 inward and 6 outward photon paths. energy level of the electric. Here is an animation of the Schwarzschild star configuration, and it's composed of 12 spines going in and going out, the primary paths of the photon. And we've all seen this animation or this funnel before. This is called the paraboloid of the Schwarzschild. But these are all the energy funneling out, and it creates a torus because it doesn't just go out forever. It will curve right around and come back in again in that flowering shape that we see in the Schwarzschild metric of the universe versus the Newtonian. But this is one part of the inward energy and outward. So here is the positive pole, and here's the negative pole, and then it goes a 45-degree angle and goes back in again. Whoops, there we go. Anyway, it goes in these intricate turns, and they keep turning and turning and turning and turning, going in and hitting and turning out and turn. It's like the turn of the screw or the ticking of the clock. It keeps on rotating, but it's always in a forward motion because it's 2 steps forward, 1 step back, because the magnetic pull is not as significant as the forward movement of the photon. Many people have wondered what the Great Pyramid of Giza represents. And basically they have marveled at how this pyramid matches all the constants of physics, etc., and they have not been able to understand who built it, why it was built. I propose that the pyramid is a geometric representation of the quantum density of the entire universe. That is why all the constants can be found in its height to length to slope to inverted slopes, because it is a representation of the entire universe built on a quadrupolar double-sided octagon, twisted one 45-degree angle, and so you're going to have the down-flowing current, and then you're going to have the upflowing current, down-flowing current, twist 45-degree angles, and upflowing. This is the Schwarzschild metric in stone. And the Schwarzschild metric determines the entire field equations of the universe and the quantum density of the universe. The video that you just saw, which was an excellent video, basically said at a 90-degree angle, if you place 2 filters, the photons are blocked completely, 100%. But if you twist the filter by 45 degrees, the photons are blocked only 50%. So 50% travel through and 50% are refracted outward in a different direction, obviously. I mean, when you block a photon, it's got to go someplace, so it doesn't go through the filter, it goes someplace else at a refracted angle. But there's some that are traveling through the straight angle, and 50% of those photons are able to hit through there at a straight line, while 50% are refracted at a different angle. And it's going to be refracted at the 45-degree angle. So the question is, why at 22.5, which is half of the 45-degree angle, why are only 15% of the photons blocked? Well, it's simple math, and I'm going to show you it right now. Let's just say a photon travels at, let's say, the ratio of 6.6, okay, per the magnetic. But so we're just
we're splitting it. We're not going to be dealing with the magnetic speed of the wave, but only the photonic speed of the wave, which emerges out of Planck's dimension at this speed. So we're going to, so at 6.66, that's going to be at the 90% angle. So let's divide it by 45 or 50%. So 50% of 66.6 is 33.3. All right. So at half of 30% again, which is the 22%, 22.5 angle. So let's divide 33 again by, let's times it, by 50%. And you get 166, or closer to 15% than the 25% those two gentlemen were talking about. That's very rational. I saw that instantly in my head. And that's because I'm not a mathematician. I see things differently. And so can you see how easy that is for me and how difficult it is for a mathematician? But of course, one of them is only a mathematician, so he would not know about the speed of light that well. The other one was a physics guy, so I'm having to question why this would be such a weird concept for him. So in other words, yeah, when you're blocking only 22.5% at an angle, you're going to get 85% of those photons traveling through. And that's why when you add the filter, it polarizes them out, and 2/3 more photons go through before it flips to the magnetic and blocks. So it's traveling 2/3 faster when you add the filter. I don't know if that makes sense. Makes sense to me in my head. So we're going to have to figure it out, and I'll have to write a paper. But I'm not kidding. These scientists really don't listen to anybody. They've got to be told what to think. So anyway, simple solution to not that difficult of a problem. Now I'm going to show you why light travels the way it does. And it's based on the Schwarzschild metric. And what the Schwarzschild metric says is that a photon will travel here at C. And when it hits C, it's reached its inertial mass. And it flips, and the photon will skid off this way, and the electron that it just hit to flip it is going to go at another 90-degree angle. That's the Schwarzschild right angle way of the photon and the magnetic wave. Photon this way, magnetic wave this way, they flip and they go at right angles to each other. But when they hit out here, they're hitting another inertial mass, and so they're going to flip again, and they're going to go up here to a 45-degree angle, where they're going to pick up another net wave, and this is the wave direction, and they're going to hit their inertial mass here, and then they're going to speed down here, and then they're going to go up here and down here, and anyway, it's in an octagonal shape of 45 degrees. But then if you add a third dimension, this is the flat dimension. If you add a third dimension and twist it, which you'll see in the Star of David, or an octahedron, a 3D octahedron, or what should I say, a Merkaba, the Merkaba star. I think that's an 8-pointed star. I can't remember. But you're going to have other streams coming in this way at 22.5, and you're going to have, okay, this dancing between strings of photons flipping into magnetons, flipping into photons, electrons, magnetons. Anyway, it's flip, 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 flip at the speed of light until the photon emerges after it picked up enough energy again on another trajectory. And quantum physics can predict up to a 15% differential which direction it's going to emerge from. But it's the extra 15% that we don't know about because we don't have enough information yet. That doesn't mean science will not develop the measurement or the instruments to determine this. But right now we have a 15% always invariable that we cannot predict. And that's because we've got this configuration and light streams and these right angles. Twist, you go up here and you twist just 1/4%, and then you come down here and you keep going, you keep twisting. And if
Which brings us back to the issue of the filters. At a 90-degree angle, all photons are black. At a 45-degree angle, only 50% of the photons. And at 22.5, 85% of the photons go through. Amazing. I'm going to propose a solution, and it involves conservation of energy.
But here's where things get quantumly bizarre. All these filters do is remove light. They filter it out. But if
So can you catch the fallacy of their reasoning? What the Schwarzschild metric states is that through conservation of energy, a photon will avoid a head-on collision with a magnetic field, which is at the 90-degree level. So as they introduce A and C, C gives you a 45-degree level of energy, photons, and basically lets only 50% of the photons through, because half of them are colliding with a magnetic field, but the other half are skidding off. But if you add the filter in between, it negates this filter C, because what happens is it allows, at a 22.5 degree refraction, those photons are refracting out on a different trajectory or spine of the Schwarzschild metric, and it allows 85% of those photons to shine through, with only 15% being blocked. So you basically negate C, and you're using only really two filters, A and B, because C only catches about 15% of those photons that fail to skedaddle up here on the 15% or the 22.5 incline, and the rest of those dummy little old photons did a head-on collision with C. So that's the solution that I propose. We'll have to see.
A fundamental element of human nature is the need for creative work, for free creation without the arbitrary limiting effects of coercive institutions. That a decent society should maximize the possibilities for this fundamental human characteristic to be realized.